Alright guys, today's goal, the learner will understand two-dimensional vectors, vector operations, unit vectors, direction angles, and applications of vectors. These topics are important to many real-world applications, such as calculating the effect of the wind on airplane's path. Okay, so let's take a look at the first example here. Alright, a directed line segment. A two-dimensional vector V is an ordered pair of real numbers, denoted in its component form. Notice their angles, they're not the curves of the ordered pairs, okay? The numbers A and B are the components of the vector V. The standard representation of a vector A comma B is the arrow from the origin to the point AB, so right here. And just like in slope, there's your A distance, there's your B distance, okay? The magnitude of V is the length of the arrow, and the direction of V is the direction in which the arrow is pointing, okay? So see how this is telling you it starts at 0, 0, the origin, and goes up in that direction. That's why the arrow is pointing that way. It's not saying it goes on forever. That's just the direction that the vector was moving. The vector 0 is 0, 0, and it's called a zero vector. It has a 0 length and no direction. Okay, so let's look at pieces of it. Let's look at how we can find the magnitude, okay? All right, so if V is represented by the arrow from x1, y1 to x2, y2, then the absolute value, which this means magnitude of V, distance formula. Okay, we've done this. If you're given the vector form of V, then the magnitude is just a squared plus b squared square rooted. Okay, so we've been given these. So this is how we calculate these. So let's take a look at how we can do one. It says find the magnitude, V represented by PQ. Okay, so label x1, y1, x2, y2. The magnitude of V is 3 minus 5 squared plus negative 4 minus 2 squared. So you get 40, which is 2 square root 10. So there is our magnitude. So now we've figured out how to name the vectors, how to write the vectors, and then how to find the magnitude. Now we need to talk about the direction piece of it, okay? Okay, so vector addition and scalar multiplication. Let U be U1, U2, and V be V1, V2. Be vectors, and let K be a real number scalar, okay? The sum or resultant, that's another way they use the word, of vectors U and V is U plus V. Add U1 plus V1 and U2 plus V2. So add the x's together, add the y's together. The product, distribute to both. Okay? So let's take a look at this. So let U be 2, negative 1, and V be 5, 3. Find 3U plus V. So if I set this up, I have 3 times vector U plus vector V. So that would be 6, negative 3, plus 5, 3. And then this would be 6 plus 5, negative 3 plus 3. So we have 11, 0. Okay? So that's how we do those. Now let's take a look here at the unit vector. Okay, a vector U with a magnitude of 1 is a unit vector. If V is not the zero vector, 0, 0, then the vector U is the vector V divided by the magnitude, which is 1 divided by the magnitude times the vector V, is a unit vector in the direction of V. Okay, so let's take a look at trying to do a unit vector. So find a unit vector in the direction of V 2, negative 3. So first thing we got to do, find the magnitude. Okay, so the magnitude, 2 squared plus negative 3 squared. Square root of 13. So then the unit vector, so you would say you do 2 divided by the magnitude, comma, negative 3 divided by the magnitude. So there's the unit vector, okay? So now that we've figured out magnitude, unit vectors, now we have to take a look at the direction. So let's take a look at that. Resolving vector. If V has a direction angle theta, the components of V can be computed using the formula V equals magnitude times the cosine, comma, magnitude times the sine. From the formula above, it follows that the unit vector direction of V is V divided by the magnitude of V, which equals cosine, comma, sine. Okay? So let's look at the first problem. Find the components of the vector V with direction angle 120 degrees and a magnitude of 8. Okay? So, if we're looking at this right here, see how it has magnitude times cosine of theta? If we set that up, you get your vector is 8 cosine 120, comma 8 sine 120. Well, what's the cosine of 120? 1/2, so you have 4. The sine, or negative 4, because it's negative 1/2. What's the sine of 120 degrees? Square root 3 over 2, so it's 4 square root 3. So there is the vector and the direction. Let's try another example. So find the magnitude and direction of an angle U, 2, 3. So watch. Find the magnitude first. So the magnitude of U is 2 squared plus 3 squared, so 13. So now we have this. Square root of 13 times cosine of an angle, comma, square root of 13 sine of an angle. Well, we know that the square root of 13 cosine of the angle times the cosine of the angle equaled 2, and the square root of 13 times the sine of the angle equaled 3. So you need to pick one of them to solve. So watch. Square root of 13 cosine theta equals 2. So you would get theta equals the inverse cosine of 2 divided by the square root of 13. So you can hit that in your calculator, or you could have had inverse, or theta equals the inverse sine of 3 divided by the square root of 13. Make sure your angles are in degrees right now, so your calculators are in degrees, but those will give you the exact same angle. So the magnitude is 13, and the direction is 56.31 degrees. Okay, so the velocity of a moving object is a vector because velocity has both magnitude and direction, often seen in physics. The magnitude of velocity is speed. So if you're just looking, when you're driving a car, when you say you're traveling at 65 miles per hour, that's the speed. When you say you're moving northwest at 65 miles per hour, that's your velocity. Okay, that's just a basic example. But we need to understand the difference in these. See you guys tomorrow.